In this next video, we're going to talk about creating end conditions. This is group exercise number 2. First thing we need to do is have a Microstation file open, and we happen to be in the plan_J2P0200.dgn. And in step number 1, they want us to create or select the create template icon, and that's located under corridor modeling under your task, civil tools, corridor modeling, and then this icon right here, create template. Since I was just in the create template dialog for the first exercise, it opened up my J2P0200 ITL. If this is pointing to the MODOT ITL, you'll need to do a file open. The next step, what we need to do is we need to navigate down to the J2P0200 folder, and we're going to create a new folder called end conditions. So we're going to right click on the J2P0200, we're going to do new folder, we're going to call this one end conditions. Under end conditions, we're going to create a new template called slopes 6:1. So I'm just going to right click on end conditions, do new template. I'm going to call it slopes 6:1. Now, out in the blank area, what we're going to do is we're going to right click, we're going to go to add new component, and we're going to go to end conditions. So we're going to add a new component called end conditions. Once that comes up, we're going to come down to the name, and we're going to call it fill, this first end condition. The cross-section feature is going to be excess ground proposed. So we're going to click on this, and we're going to slide on down to excess ground proposed. We're going to target type terrain model. It's going to be a priority 1. And the active terrain model we're going to use. In this exercise, we're going to use the dynamic setting, so I'm going to bring that up. This is going to be in step number 6. We go to dynamic setting, which is located right here. And in there, we're going to use a point name called fill slope T, and this is in the MODOT point name list. So we're going to go to that, and we're going to drop down to one called fill slope T, or fill slope top point. Again, our point style is going to be excess ground proposed, and our apply affixes is disabled. Again, we're going to talk about that later in a later exercise. And our precision input is going to be X, Y, and that's going to be 0, 0, because we want to start right on this origin point right there. So 0, 0, and once I have it in there like so, I'm going to go ahead and hit enter. And you can see I'm starting to draw my end condition. For the second point, we're going to set up the dynamic settings like so. We're going to check for interception. We're going to place point at interception. And we're going to say end condition is infinite. We're going to leave the do not construct unchecked. The point name is going to be fill slope B for fill slope bottom. So we're going to go out there and find the B point. Again, apply affixes is disabled, and the precision input is going to be HS, which is a horizontal distance and slope of 30 feet, comma, -1:6. Once I have that in there, all I have to do is hit the enter key, and it'll place my slope out there. Once I place that point, I'm done with this fill slope, and I can right click and finish. What a lot of people like to do is just do a fit view when they're done, and everyone's should look similar to what we have here. Again, what we're going to do now is we're going to put in a ditch slope, and typically we keep these separate. They are separate in the MODOT library, but for this exercise we're going to put both a fill and a ditch in the same template window. So what we need to do in step number 10 is we're going to add a new component. This time, again, it's going to be another end condition. This time it's going to be called ditch, so we're going to change the name from fill to ditch. Excess ground proposed again. Again, we're targeting a terrain model, and we're going to do the active terrain model. Again, the priority is also going to be 1 on this one as well. So again, we're going to use our dynamic settings to place this, and we're going to change our point name from fill slope B to ditch 4 slope 1T. Ditch 4 slope 1T. Again, we're going to use excess ground proposed for our point style. Again, disabling apply affixes. And again, we're going to start off at an XY of 0, 0. Once we have that in there, we can go ahead and start placing this ditch. You can see it's starting at the same location as our fill slope. The next point we're going to store is the ditch 4 slope 1B, and that's on step number 13. So we need to go to our dynamic settings. We're going to change our point to ditch 4 slope 1B for the bottom point. We're also going to disable check for intersection because we want the ditch to draw. End condition is infinite. We're going to turn off as well. And the place point and interception is ghosted out now. For this point, for the point name, we've already set it to ditch 4 slope 1B. We then need to put in a precision inputs of h sub s, which is going to be a horizontal distance and slope, and that's going to be 24 feet, comma, at a -6 colon, or 1:6, -1:6. Once we have that in the field, we can hit enter, and you can see it's following our fill slope, because it had a 6:1 slope as well. Now we're going to draw in our bottom of ditch, and we're still going to have the same settings turned off on this. We don't want to check for interception, and turn off end condition is infinite. This time we need to change the point name to ditch back slope 1B. And for this, we're going to use an h sub s of 4 foot to the right, comma 0 for the slope. Once this is set, we can go ahead and hit enter. And now we're going to draw that back slope, and this is when we're going to start looking for the interception point. We're going to place a point at interception if it falls between this end point that we're defining. And if it does not fall between this point and the previous point stored, this one and wherever this point's going to be stored, it'll extend that back slope up until it hits the surface. So we want these three turned on. For the point name, we want ditch back slope 1T for the top point. And for this one, we're going to do again h sub s. But this time we're going to do 5 foot, comma, at a 25% slope. And you have to use the percent sign. Again, once you have this all set, all you have to do is hit enter, and it places that slope out there. Once you're done with it, we can go ahead and right click and finish. And then again, you can do a fit view if you like. So again, we've got a fill slope and a ditch in this one template window. Now to check this, what we're going to do first is we're going to save, and then we can come down to where it says test. When you hit the test button, it says, hey, the template has end condition priority conflicts. Use the check priorities button to view and fix. Okay, so I'm going to go ahead and make this bigger so we can see it. But you can see there's our fill, it's kind of ghosted out, and there's our ditch. And again, it's ghosted out. And so we're going to come up and check our priorities, and it's coming off this one point right here, this fill slope T. So we're going to edit it. And you can, when we created these components or these end conditions, we used a priority 1 for the fill and a priority 1 for the ditch. And so what you want to do is you want to make one of these higher, a higher value. The value that's higher would be the secondary, would become a secondary priority. And so what we're going to do is we're going to make the ditch be a number 2. So if there's a point or surface that is drawing in a certain area, the fill slope will take the higher priority and draw the fill. And then if there's a situation where the fill does not a valid solution, then the ditch will then draw. To show you this, we'll go ahead and hit OK to this. We're going to say close, all of our conflicts are gone, and we're going to hit the draw button. It's going to put out there a kind of a fake active surface at a 0% slope, and if I hit draw, you can see the fill is drawing, and if I go above that beginning point, then the ditch draws in there. Now typically that's not the way we have our fills and ditches work, or our end slopes work. What we normally do is have the ditch come all the way down to the bottom of the ditch, and then when we get past the bottom of the ditch, then the fill kicks in. So what I'm going to do is I'm going to flip the priority of these end conditions by going up to the check priorities. It's telling me, hey, there's no conflict. Do you still want to edit this? And we're going to say yes. We're going to edit this point where the 2 end conditions are coming out of. And so this time I'm going to just make the fill a 3, and because the ditch is a lower number, it will have now a higher priority. And so now if I hit OK to that and then close, you can see that even though I'm down below the fill slope point, before it was just drawing the fill, but now it's drawing the ditch because it's a higher priority. And once I get down below the ditch, then the fill kicks in. And so that's what those priorities do. It tells the program, depending on where this surface is, which item to draw first if both can solve. And so this looks good, so I'm going to go ahead and close this down, and I'm going to go ahead and file save again since we changed the priorities of the 2 end conditions. So that's all there is to creating end conditions and testing them. And so we're done with this second group exercise in Chapter 5.